Hello, welcome to Season 3 of the Leukopak Lady. Thank you so much for joining me. This season, I want to go beyond just talking about leukopaks and cellular starting material. I want to shape the thinking of this field based on everything I've learned from collectors, developers, and regulators. Last season, I said that in 2026, allogeneic program growth won't be limited by manufacturing capacity, but instead would be limited by donor biology. Today, I want to talk about what good starting material actually means now, because a 2018 definition no longer works in a 2026 industry. Traditionally, a good leukopak meant there were enough cells present, the cells were viable, contaminants like red cells, granulocytes, and platelets were at acceptable levels, and the collection and shipment process did not deviate from established procedures. If the cells were alive, abundant, and arrived on time, we called that a win. This definition made sense for early-stage allo programs focusing on proof of concept and process development, and variability was seen as a future problem to tackle, or not. However, when programs begin to scale, this basic definition breaks down. Manufacturing inconsistencies pile up, clinical outcomes vary unexpectedly, and even when leukopak specs are similar, different outcomes are documented. Variability that can't be seen at a small scale doesn't disappear as the therapy goes through its life cycle. It compounds. So let me introduce a new framework. 4 pillars to define good CSM for the future of allogeneic cell therapies. First, quantity. Knowing the number of cells is still important, but no longer enough to define good. Next, composition. This is specific subsets of cells, not just PBMCs. Cell ratios, surface markers, knowing what's really in the bag. Functional fitness. Knowing what the expansion potential is, resistance to stress during processing, and the ability to kill targets. And this needs to be defined in the donor pool first to help choose which donors to collect from. And finally, predictability. Consistency across donors, collections, time, and scale. This is currently the most underappreciated metric, but a very important one. So the best CSM is reliably good, and so predictability is the real upgrade here. In 2026 and beyond, regulators and investors will care about predictability because it impacts patient outcomes, affects timelines, and influences future approvals, which ultimately hit bottom lines. So now let's talk a minute about hero batches, which are manufacturing runs that succeed perfectly. These actually become a huge risk, and they don't mean that the process is robust. It means that the starting material for that run was better than usual. Unfortunately, programs have been built around hero batches without determining why they work so well. The goal shouldn't be to achieve a perfect batch. It should be to make every batch consistently good. And this requires a level of knowledge and control over donor biology and ideal product specifications that don't currently exist in the allogeneic cell therapy world. Therefore, developers must rethink donor strategy early in their programs and be deliberate about it. Collection centers must evolve beyond logistics to becoming partners with developers in understanding donor biology and finding and retaining the right donors. That's their sweet spot. And donor and product testing must become strategic tools to help therapies succeed. So as we develop a new definition of good starting material, does that limit CSM to just a sourcing problem, or is it something much bigger? Come back for the next episode to hear that discussion.